Assalamualaikum and very good evening to Dr. Nur Faiza. So today my group and I are going to make a presentation for our project. So this is our group member. They are Ahmad ZIKRI, Muhammad IMRAN, Muhammad AIMAN, myself and SYAZANA AQILAH.
Assalamualaikum and very good evening. My name is SYAZANA BINTI AIYOB. Today I would like to present our project on a flat plate solar water heating system. This project uses simulation to study how solar energy can be turned into heat and then use the warm water. We designed the solar collection using Autodiskette Inventor and ran the simulation in ANSYS Fleet. The goal is to understand how heat moves in the system, especially through three main methods, which is conduction, convection, and radiation. Here are the objectives of our project. First, we want to analyze how heat transfer inside the solar collector using ANSYS fluid, and then we compare the result with theory. Second, we aim to apply the heat transfer principle, conductions, convections, and radiations in a way that supports a sustainable and eco-friendly system.
Assalamualaikum and hi. My name is Atikah bin MOHAMAD. So basically I'm going to explain for the working principle of the flat plate solar water heating system. So basically there are 5 principles that we need to understand. So basically, we will easily understand the working principle of the flat plate solar water heating system through this flowchart. So first, sunlight will enter the collector where the sunlight passes through the transparent cover, and then the heat absorption. A solar plate, the dark coat soak up the solar energy, and then the heat transfer will happen. The heat will transfer to the water via conduction to the water in the flat cavity, and the fluid then warm up through convection. Next, the circulation and storage. The heat water moves naturally thermosiphon and then mechanically through the pump, and then the water will warm up and the water will store for shower, cleaning, and other use for our daily life.
Okay, so hi, my name is Muhammad IMRAN bin FAUZI and my matrix number is B13231026. Okay, so let's walk through the design of our solar water heating system where every component is engineered to maximize heat transfer while minimizing losses. Alright, just for your information, throughout these slides of the design and dimensions, I have attached the proper parameters and also its values. So let's go over the first slide where it's showing the casing and also the insulation. So for both of these components, I'll give a bit of an explanation to it. So the entire assembly is wrapped in insulation and housed in a rigid casing as stated in the picture, which locks in the heat and also prevents environmental losses, which ensures energy stays where it is needed. So for this slide, I will explain about the absorber plate and also the glass cover. So for the absorber plate, it is important to know that this is one of the core of the system. The core of the system. Its high conductivity surface captures sunlight efficiently, while integrated fins enhances the heat transfer to the water. For the glass cover, a transparent cover protects the absorber plate while allowing sunlight in while reducing heat escape. It's sized to fully shield the plate with just enough thickness to balance durability and also light transmission. So for this slide, I have attached the finished design. One is it's an exploded view, and another one is just a simple 3D isometric view. It is important to know about the flow system, which I'll explain. So the water enters through the inlet pipe, absorbs heat as it travels across the absorber, and exits hotter throughout the outlet. Natural circulation or a pump keeps the flow steady. So in this picture, I have attached a diagram with the labels on it, so we can imagine how it runs. Okay, so this design harmonizes absorption, transfer, and retention, setting the stage for the strong performance we saw in simulation.
So my name is Ahmad ZIKRI bin MAZLAN. I will present about simulation process in NSYS. So this is a machine setup. I use the automatic method for this machine. The element is 31,776 and the nodes is 19,638. So this is a simulation result. The minimum temperature we get 299 Kelvin, which is 25 to 26 Celsius. And the highest temperature we get 315 Kelvin, which is 42 Celsius. Then the center absorb the most solar energy, reaching the highest temperature. Heat decrease toward the edge due to the heat loss through conduction and convection. And the fin shape structure helps distribute heat more evenly and may drain water.
Hi, my name is Muhammad HAZIM bin AZAHAR and I will present about the theoretical calculations. Okay, for this slide, I will talk about the comparison of simulation and theoretical result. As you can see, I draw the table and the simulation shows a slightly higher temperature difference, 17 degrees Celsius compared to the theoretical value, which is 15 degrees Celsius. For conduction heat transfer, the simulation result is lower than the theoretical value. This might be because some heat was lost to the environment or due to the small errors during the measurement. For convection heat transfer, the simulation result is higher than the theoretical value. This could be the real system has more air movement or surface conditions that are not included in the theoretical calculation. In conclusion, the difference between theory and simulation are expected because real situations are more complex and can affect the heat transfer process. Okay, this is for the last slide of our presentation, which is conclusion. Our conclusion for this assignment, this simulation shows that the flat plate solar collector works well in heating water. The center of the absorber gets the hottest and heat spreads to the water through conduction and convection. The result closely match our calculation, proving the design is effective for water heating.